Alrighty. So like I said in class, the alternating series estimation theorem or the error bound thing, it's not going to be taught in this class, but it will be taught in your Calc 2 classes. So definitely use this video if you're kind of struggling with it. I'm going to go through an example on page 588 to show you guys how this theorem works. So yeah, let's jump right into it. So what is the alternating series theorem error bound? I call it the error bound. So given an alternating series that actually converges, so I'm going to call this A sub n. I think in class I called it B sub n, but it doesn't matter. So given an alternating series that converges, right? So we know that this is, it's decreasing, and right, because those are the two things. So it's like imagine you already did the AST on this, and this thing went to 0, right? So if those two things are true, you know this thing converges to some value, right? The error bound says if that's the case, then this is true. What the heck is this saying? It's saying that wherever we stop, they use the sum as like an n value, a capital N value usually. So it means that like if I stopped at like the 6th term, it would be s sub 6, or if I stopped at the 100th term, it would be s sub 100, so on and so forth, right? The error is bounded by the following term. Hence, n plus 1. That's what they're saying. That's all they're saying. They're saying if you stop somewhere, then the next term in the sequence has to be like it's kind of like a roof. You can think of it like a roof for how much you're off by. It kind of gives you like a ballpark for where the actual sum is going to live. I hope that makes sense, right? So let me kind of explain this in another way here, right? If I have a sum, right, the thing that this thing is going to go to, I can represent it as wherever I stopped plus the remainder for wherever I stopped, right? So once again, this is where I stop, and this is like the rest of the terms. So for example, if I had like, so we know the alternating harmonic series converges, right? So if I have, so real quick, as an example, if I have -1 to the n, 1 over n, right? From 1 to infinity. So if I stop at, let's say like n equals 3. So this means this thing's going to equal a sum. We know that this is going to be true because it passes AST. So the sum is going to equal 1 over 1, which is 1, right? That's the first one, minus 1/2 plus 1/3, minus 1/4 plus 1/5, minus so on and so forth. And basically, this capital N, for this example, the capital N represents the first 3 terms. But it doesn't represent the entire sum, obviously, right? There's an infinite amount of terms afterwards that exists. It goes off to infinity. That's what I call R sub n. I really hope that makes sense, right? So there's going to be 2 pieces to this. And essentially, the way they get this idea, they're saying that if you subtract S sub n to both sides, they're saying the most you can be off by, because it could be positive or negative, right? Because we're dealing with positive or negative terms. They're saying the most you can be off by, this in this case in the red, the remaining piece here, is going to be less than or equal to the following term. So in this case, it's saying you're going to be off by at most a quarter, because we stopped at 1/3. We stopped at the 3rd term. Does that make sense? I really hope that makes sense. All right. So that's essentially it. That's the heart and soul of this error bound. You're just looking at the next term from wherever you stop, and then using that to kind of create this window of where your real answer lives. So like if I were to follow through with this example right here, let me just do that. I'm just gonna follow through here. So we know the actual sum. So for this one, the actual sum when you stop at the third term is going to be bounded by the absolute value of -1/4, right? Because we're talking about amount. We're not talking about plus or minus. We're talking about amount. So we're actually just going to say 1/4. And if you guys remember how to play with absolute value inequalities, what this does is it creates this window. It says that, well, we can figure out S3, right? S3 is, what's the sum from the third term? That's 1 minus 1/2 plus 1/3. So what is that? That is 1/2 plus 1/3, which is, what is that, 5/6? Is it 5/6? I think it's 5/6, right? 5/6, because it's 3/6 plus 2/3. Yes, okay. So S3 is 5/6, right? So this is going to be S minus 5/6 is in between 1/4 and -1/4. And then we just add 5/6. So essentially what we're doing is we're adding 5/6 to both sides. I'm not going to do this in my head because I don't really have the time or care. But basically what we just did was we created a window for where the actual sum lives. And if you think about it, we can decrease the size of this window as we go out to higher values of n, capital N, right? And that should make sense, right? If I go out to 100 terms, that's a much more accurate sum than 3 terms in this case, you know? So that's essentially what this theorem is good for. It's to give yourself a certain window of where your actual answer is going to live in. All right? I hope that makes sense. If that makes sense, you can stop the video here and try some of the other examples in the textbook if you want. But if not, I'm going to do example 5. This is example 5 from page 588 in the book. And it asks you to use this theorem. All right? So part A. So the series they give you is, it's alternating, obviously. And it's, oh my gosh, it's the same one. It's the alternating series. This converges conditionally, right? I explained that in class, what conditional convergence means. So sure, let's just play with this one, I guess. It says to show that this is, oh my gosh, I'm so sorry, is less than 1/7. Show that the actual sum minus the 6th partial sum is going to be less than, oh, it's just less than, not less than or equal to. So literally all they're doing is figure out what S sub 6 is. Or rather, they're asking you to claim that this holds true. I think this one's kind of redundant, honestly. I don't like this example. Because think about it, right? If we're starting at the 6th term, I'm sorry, if we're stopping at the 6th term, then of course the 7th term is going to bound it, right? For instance, if I plug 1 in, this is, what is this? This starts on a positive? Yeah, starts positive, then goes minus 1/2, plus 1/3, minus 1/4, plus 1/5, minus 1/6, plus 1/7, minus 1/8, so on and so forth, right? They're basically saying the S sub 6, which is this piece right here, is bounded by the next term. And we really don't have to show it because this is true by the theorem above that we just talked about. It's like duh, it's kind of redundant. So I'm just gonna skip that part. Part B, it says find an n such that S sub n approximates with error less than 10 to the -3. Okay, so this one's going to require a little bit more elbow grease, right? This one's going to require a little bit more elbow grease. So basically they're saying they want the error, they're trying to get you to create a window where the error will be less than 10 to the negative 3. So what is that? That is 1, 2, 3. Is that 2 zeros or? I think it's 2 zeros, right? Yeah, that's 2 zeros. So this is going to be 0.001. Basically, you want your error to be less than 0.001, meaning how many terms am I going to need to get an error less than 0.0001? So going back to the formula, right? This is, we essentially, we want this to be less than 0.001. So what are we going to do? We're going to take the n plus 1th term of our sequence. So we're looking at 1 over n, and we want the n plus 1th term to generate an error less than 0.001. And really, what all it is from here is just algebra, right? I can just move this stuff around. I get, so 0.001 is the same thing as 1 over 1,000. So this is 1,000 less than n plus 1. I subtract 1 from both sides, and I get n is greater than 999. So, and that's it. We got our answer. What this is saying is, if you go out 1,000 terms, your error will be less than 0.001. 0.001. Yeah? All right. So that's it. That's how you use this thing, right? Just if you forget anything, if you remember anything, just to remember this, you're just looking at the following term. The next term tells you how much you're going to be off by. Okay? And that's the error bound in a nutshell. If you guys have questions, reach out. Have a nice day, and I'll see you guys next time.